Uh, Welcome back to Transcended. So we're going to answer these questions from a functions tutorial sheet. So we have a question one there which is asking us to look at these arrow diagrams and identify them whether they are functions or not. And then we have question two where we've been given g of x. We are told to answer all that. With question three there, we have question four, we have question five, and many more other questions. Okay. So before we could get to answer all these questions actually, I would just like to make some things known to you about functions so that even as we try to answer, we answer together. So I will not basically edit this video because I want to approach your questions as you would approach them as well. So the first question you'd want to ask yourself is, what exactly is a function? So there are these two terms that you're going to meet in this tutorial sheet: a relation and then also a function. So one thing that I would want you to know is that all functions are relations, and then not all relations are functions. So it's like you've got this big set called the relation, and then within that set there are some relations which are also called functions. Okay, so of course you know what a relation is because I'm sure you know what relationships are, right? It's like there's a connection there. So usually what we use when explaining this, we usually use x and y, where we usually call x to be an input value and then y to be an output. We usually use these and then we perform kind of a mapping there. So mapping basically just demonstrates the relationship that is there. Okay, so if we can have 1 and 2 there, and then basically you can have, let's say, a 2 there and a 4 there, and then I map them like this. So you're able to agree with me that the relationship that is there between x and y is x mapped onto y. What you're saying there is y is going to be what? It's like it's supposed to be doubled, right? It's like x squared. Not x squared, it should be 2x. So now to be smart about it, I would have to say, I would have to put it this way. Y is equal to 2x. So if we've got the value of x, if I plug in there, I should be able to get the value of y. So that is an example of a relation. And of course, it is a function. Now, what exactly is a function? And how is it different from all relations? So, what you need to understand, a function. A function is of course a relation. So, a function is a relation where every input has a what? A result. So what result is what? An output. So every input should have an output. Okay? And that output should be unique. Okay? Unique output. What that means is, in cases where you have, let's say, A, and then it's giving you different results, that is not a function. You expect that A should only be able to give you one result. Okay? An example of a function is, if I give you an equation x plus 2. Okay? So if I'm trying to find the value of y, I should just plug in the value of x there. So f of 2 is equal to, where there's x, I'll put a 2 plus 2, giving me a 4. That's an example of a function. So I don't expect to put the same value 2 in that function and then get two different results when it's not a function. That's a basic idea there. Now, we'll look at question 1 and try to identify some of these. We'll disqualify some of them. Okay? At least from what we've talked about. So question 1 says, state which of the following relations given by the arrow diagrams are functions. So we'll look at A first of all. Let's try to observe A. So this is our input. They are all mapped to something, and they are all mapped to unique things. So of course I would like to mention to say a function where every input or where every output is mapped onto something is called an onto function. Okay, and then where each one is mapped to a unique one, again it's also called one-to-one. So in this case we have a one-to-one functions. It's a function because every input has an output. We go to B. Is it a function or not a function? I think you've seen the key term I've been using. Every input should have an output. So in this case B doesn't have an output, so this is not a function. B is not a function. If you look at C, A, B, C, D. Now this is where it becomes tricky. This is where it becomes tricky, and most of you are already lost there. Is it a function or not a function? So every input is mapped to an output. Is it a function or not a function? So in this case, this is also a function. It is a function because every input has an output. So is it possible for you to have many inputs having the same result? It's very possible. I like giving this example. F of x is equal to x squared. Do you agree that if I was to use 3 and negative 3 as my input values, for 3 squared it will be 9, for negative 3 squared it will also be 9? Is it true? So this is proof enough that it's possible for us to have different input values giving us the same output. So we actually call such a function to be a many-to-one function. Okay, so a many-to-one function. But we don't have what we call one-to-many function. Now it becomes a disqualification where you are using 3, for example. In the same function you put 3, in the same function again you put 3, and then it gives you different values. Let's say 7 and then negative 7, same value. That doesn't exist. That's what we reject. Okay, so if this was the opposite, if we had the 4 being mapped to different things, it doesn't exist in such a case. Don't mix up the information there. Very, very important. Okay, we're now on D. What do you think? Is it a function or not a function? So observe the way the inputs are working. A, B, C, and D. So A is mapped to 3, B is mapped to 3 as well, C is mapped to 1, D is mapped to 1. So at least everything in the input is mapped to something. And then we've already talked about that case. It's possible for 2 input values to give you the same output. So that is still a function. Now some of you have already been observing that from C, we've got no issues by having output values without an input. That's not a problem. It's possible. Of course, under programming, I would give you such examples. For example, if you're checking the time, right? What's the current time? Current time is, of course, that is under programming. But of course, think of it in real time. Like, if you're checking the time on the clock, or if you ask someone to say, what's the time? They'll just tell you if it's 14 hours, 14 hours. There is no input value there. Or even if you're checking your phone, you don't have to put any input value for you to get the time. You just check the time. So that is an output directory with no input. And then we'll go to E. Observe A, B, C, D. So the basic definition of a function, I was saying every input value should have an output, right? So in this case, A and B don't have outputs. So it is not a function. Then the last one, A is mapped to 4, B is mapped to 1, C is mapped to 3, D is mapped to 2. So this is also an onto function, one-to-one function. So at least every input is mapped to something in the output. And we don't have a case where an input is mapped to 2 things. So if we can have B mapped to 2 different things, then it is not a function. Okay, but in this case it is a function, unless otherwise. Okay, so that is just a basic introduction to identifying relations which are functions and which ones are not. Okay, so later on we'll look at how to prove an onto function, how to prove a function is one-to-one. We are now on question 2. Question 2 A says, given that the function g of x is equal to that, find that. So that one is very simple for all of you, but I'll still answer. So functions are not as hard as people make it look sometimes. Some even just math generally, like there's just this misunderstanding, this belief, this myth around that it's complicated. Just take time to understand certain principles, the basics, you'll be able to, you're home and dry. So the way you basically get to do with functions, these are things we've been dealing with from high school. So if you look at part 1, which says g of 4, what that means is where there's x, please put a 4. So I'm just following g of x itself. So we have x squared there, so I'll put 4. Where there's x, I'm putting the 4 minus 6. What's the answer? 4 squared is what? 4 times 4 is what? 16 minus 6. The answer is 10. Part 2 says g of negative 4. This is where you have to be very careful now. Your x is negative 4. Now it is still squared minus 6. That is still 16 minus 6. 10. Now this is a case where I was talking about to say it's possible for you to have two different input values but have the same result. It is still a function. And then finally we have g of 2. G of 2 requires us to substitute a 2 where there is x. So 2 squared minus 6. 2 squared is a 4. 4 minus 6 is a minus 2. So we've answered question 1 to question 2a, 1, 2, 3, and then we're on 4. Find the possible u values of a. Possible values of a. So this was supposed to be if g of a is equal to a. So I can erase this. I believe you've understood how to go about all that. I was expecting them to put at least the inverse part, where they say find the g negative of x. So cover that later on. So we are saying g of a is equal to a. So what does g of a mean? G of a means where there is x squared, put what? A, right? So in such a case, on the left we're going to have a squared, where there is x, I've put a minus 6. Then it should be equal to a. So now this takes you to a quadratic function. You you take them on one side, it will become a minus a, and then minus 6 equal to 0. So usually, for me, the first option I usually take when I'm trying to solve a quadratic function is, first of all, I'd have to try out if it's possible for me to factorize that. So the product is, you look at the coefficient of the squared part with the constant. So negative 6 times 1 is, so my product is negative 6. My sum in between is the coefficient of the middle part, which is a negative 1. Think of two numbers that you can multiply to give you the negative 6, you add them to give you a negative 1. So I can personally think of 3 and a 2. I just need to understand now where so if I'm adding getting a negative, it means the negative is supposed to be on the bigger number. That's why I said this video I'm not editing. I'm trying to use a language that everyone is familiar with. So negative 3 multiplied by 2 is negative 6. Negative 3 plus 2 is a minus 1. So those are our two factors. So the way it works is those ones will substitute the middle part, right? So I have a minus 3, and then you have in the other bracket a plus 2 equal to 0. So if you try to make you get what is in the brackets now equated to 0 separately. So this one will give me an answer of a is equal to positive 3, the other one a is equal to minus 2. So these are the two possible values of a. Okay, so that's it with question 2a. So if you are one of the people who wants to learn this topic from like scratch, there's a link in the description there. There's also the WhatsApp link to the WhatsApp group, and then there's also the contact, the person you can get in touch with if you'd like to have access to the videos from scratch and also attend the classes where you get to learn everything in details and you have access to all the tutorial sheet questions, solutions that is. And then B, f of x is equal to 2x plus 1. Find f of x squared. I think it's just about understanding the language that has been used now in this case. So what it means when you say f of x, and then for me I like using parentheses for that, or different brackets actually, the square brackets, I call them square brackets, squared. So I want you guys to understand that there's a difference between that and then it's different from this, where I say x squared. This language means whatever is inside those brackets, it means you substitute where there's x in the function. Now, when you square the entire function, including the f itself inside there, it means that what you're doing is this. So substitute, what do you know in this case? You know that f of x itself is 2x plus 1. Now what are you doing is you are squaring this. That's what we are doing. So perform this normal algebraic multiplication. So we have 2x plus 1 multiplied by 2x plus 1. So let's try to multiply that. 2x times 2x is 4x squared. 2x times 1 is 2x. So it repeat to be 4x and then plus a 1. So that's our answer. So this is what I was trying to say, that this is different. I didn't even pay attention that it was there. So that is our first part. It's very windy where I am. Just close the window. And then we are on the second one. F of x squared. This is different. I said what that means is where there's x, you basically get to substitute x squared. So you have 2. Now where there's x, we'll put what? We'll put x squared and then plus 1. So you end up having 2x squared plus 1 as a result. And then the other one, which is like the last one, very interesting. So feel free to pause the video and just try that one out. So we have f of x. So what does that mean? So what it means is it's like you still have the normal function. Now the input value is the function itself. That's how interesting it is. If you still want to understand it more, you can even write the function itself, which is 2x plus 1. Now where is x, we are putting what? F of x. Now don't forget, in the function we've got 2x plus 1, so it is plus 1. So now f of x is the input itself. So the function itself is 2x plus 1 plus a 1. Don't forget. So you have 4x plus 2 plus 1, giving us an answer of 4x plus 3. Okay, so that's it for question 2. We are now on the third question. I've not even paused the video. I'm just still going on. No editing. Okay, so just taking some water. Question 3a. The function g is given by g of x is equal to x squared minus b, where a and b are real numbers. If g of 2 is equal to that, g of negative 1 is equal to that. Find the values of a and b. So each time you're looking at all these, think of quadratic simultaneous equations. Yes. So pause the video and try that one out. So you've got g of x being equal to ax squared minus b. That is your function. Now for the first one, we've said g of 2 is negative 5. G of 2. So I'll write that g of 2 is equal to negative 5. Now, g of 2, what that means is where there's x, you put the 2. So we'll look at the function itself. So I'll say a, where there's x we are putting a 2, so it will be 2 squared minus b. So now we know that g of 2, the result in the question has been given to be negative 5. So put negative 5 on the left. Is that a 5 or it's an s? So negative 5 is equal to, now 2 squared is 4, so we have 4a minus b. So we have our first equation. And then I'll use white for the other part. So we have g of negative 1 as well. So what that means is in the function where there is x, you put negative 1. So for the g of negative 1, the question tells us the answer was a 2. So equal to negative 1 squared is 1. So it will just be a minus b. So we have these two quadratic. We've got these two simultaneous equations because we expect that the value of a and b should be the same in both equations. So for me, I feel working with the one on the right is easier, where I can just make a the subject by taking b the other side, so that we have 2 plus b is equal to my a. So I've made a the subject, and then I'll come back to this other equation where there is my a, I'll put that. So 4a, now where there is m, I'll put 2 plus b minus the b, which is coming from there. So at that point, we just have b, we're able to find b. So we've got negative 5, 4 times 2 is 8, 4 times b is 4b minus b. Can collect the like terms. On the left, I can take 8 there, so that it becomes negative 5 minus 8, which I believe should be able to give us what? What do you get if you add 5 plus 8? You get the 2 from the 5, it gives you 10, you remain with 3, so it will be negative 13. And then 4b minus b, it gives you 3b. Divide both sides, your b becomes negative 13 over 3. I'm not so comfortable with finding fractions, but anyway, that's what we have. So for me to find the value of a, I'll just go back to the other one, which is 2 plus the b. The b in this case is minus 13 over 3. So the faster way of simplifying that is multiplying the 3 by the 2, or you can come with a common denominator. It's the same. 3 times 2 is 6. 6 minus 13. What's that? 6 minus 13. So the difference should be minus 7. So negative 7 over 3 as your answer. So we found both values of a and b. Now if you look at b is now has begun now dealing with the domain and the range. So what you need to understand is the domain is basically the input values, what possible values are able to plug in that will still define the function. Then the range is what are the possible results that you expect. Okay. And then a one-to-one function is a function where each input value is mapped to something in the output, only a single value, one-to-one. So there's a way we get to prove that. Okay, so we'd have to prove some of these are one-to-one and disqualify the others, and also give the range. The domain has already been given. So looking at the first one, negative 2 is less than or equal to x, less than or equal to 4. What this means is, now there's that first part which says x is a member of real numbers. So real numbers, this is like we did set interval notation. So all the real numbers between negative 2 and 4 themselves are included. So if we are to use these values, what are the possible values of y do we expect to have as a result? Okay, so this evening, if you're watching this video on what? On 12th April 2023, we are going to continue with the students who've registered. So like I said earlier, there's a link in the description and there's a contact you can get in touch to basically get registered for the class, and you learn everything from scratch. Not only will you learn, but you also have access to videos that explain all these concepts step by step on our Moodle platform. So get in touch with that WhatsApp number and get ready for your assessments ahead of you Don't forget that you also have access to everything you've learned: complex numbers, binary operations, surds and set theory. Okay, so all these questions will be answered this evening. Okay, so thank you very much for watching. Make sure you share this video with your fellow NS students.